Hello everyone, and welcome to this detailed session on system management in open process automation. My name is Mohammed Almaz, and I am the Global Pre-Sales Lead for Open Automation Solutions at Schneider Electric. Today, we will delve deep into Part 5 of the OPAS standard, System Management. To begin, let's examine the fundamental problem we face. OPAS systems comprise control and non-control components sourced from multiple vendors. Managing the computing hardware, network infrastructure, and software lifecycle from this wide array of vendors introduces several challenges. There is a need to ensure that each piece operates efficiently and harmoniously, but this is easier said than done when dealing with disparate systems. This becomes a management challenge, not only from a technical standpoint, but also from a logistical one. Operators need visibility into the status of all components, and they need to be able to update, manage, and troubleshoot these components without vendor-specific knowledge or reliance on proprietary tools. In today's dynamic industrial environments, maintaining a consistent approach to manage both hardware and software, especially for multi-vendor setups, is critical. To solve these challenges, we need a unified approach that enables seamless lifecycle management, irrespective of the vendor. We aim to introduce a standard interface for granular reporting and action on all OPAS components. Imagine having the ability to manage your entire infrastructure from one dashboard, whether it's a DCN, network switch, application, or Docker. All can be accomplished through this unified system interface. Essentially, we need to create a management solution that makes it easy to plug in any component from any vendor and manage it seamlessly with everything else in the system in the same way. Why this is so important? System management is the backbone of operational reliability and efficiency for OPAS systems. Openness and interoperability are essential to reduce vendor lock-in, ensure system scalability, and provide flexibility. If you have an infrastructure that allows you to mix and match different vendors' components without facing compatibility issues and without introducing extra components management challenges, you can adopt the best technologies at any time, essentially future-proofing your system. There are also some added values that this solution brings. First, it helps us enhance uptime, which means fewer unexpected disruptions in operations and a lower likelihood of production losses. This value is introduced in Part 9, System Orchestration. The unified interface also simplifies overall system management, directly reducing complexity and cost. By introducing automated tasks like node discovery, onboarding, and firmware updates, we can save significant time and reduce the risk of manual errors. Another valuable aspect of this solution is compliance with IEC 62443, a key standard for industrial control system security. Such standards guarantee a robust security framework across all system components, allowing us to manage cybersecurity risks more effectively and achieve our aim to have secure by design components. We leverage a known industry standard, DMTF Redfish, to realize this vision. Redfish is a modern, open, and well-known standard designed to help manage and control hardware in a simple and consistent way. It has been widely adopted in the IT world for hardware management, and its advantages make it a perfect fit for the industrial automation environment. It is scalable on standalone machines or racks of equipment, flexible, and can be implemented through existing hardware or as a software service. Extensible, can easily add new and vendor-specific capabilities to the data model. Backward compatible, can add capabilities while preserving investments in earlier implementations. Interoperable, provides consistent functionality across multiple vendor implementations. standards-based, built on ubiquitous and secure protocols. It is still easy to use without requiring highly specialized programming skills or systems knowledge. Finally, it is lightweight and designed to reduce complexity and implementation costs, minimizes the footprint needed for implementations. Redfish is built on RESTful API principles, meaning it works over standard web protocols like HTTP, HTTPS, and uses simple methods get, post, put, delete for communication. Data is exchanged in standard formats, making it easy to read and parse. This simplicity makes Redfish accessible to anyone through a sample web browser, reducing the need for specialized skills. For example, if you want to check the status of a particular system component, you can send a GET request to the appropriate endpoint. An endpoint represents a resource, a service, or even a collection. A collection is a group of like resources. It can represent a logical, physical, or even a collection of managers. So if you send a GET using a browser or any HTTPS client, the API returns data in a human-readable format, making it simple for administrators to understand the information being returned. Now, let's talk about the Redfish schema. The schema is the core of how Redfish defines system components. It provides the structure, properties, and behavior of each resource. Each schema has a revision, allowing Redfish to evolve while maintaining backward compatibility. The schema defines everything, from applications and distributed control nodes to metrics agents and operating systems. The advantage here is that schemas provide a consistent framework for managing system resources across different vendors. It allows vendors to add their specific features without breaking compatibility, making it a truly open and flexible approach to system management. To overcome some limitations with the original DMTF schemas, it was important for OPAS to introduce multiple new schemas essential for managing various components within the system. For example, a distributed control node schema is a key element for managing a DCN across the system. An operating system schema defines the management properties for the underlying OS of control nodes. The flexibility of these schemas allows us to manage a diverse set of resources consistently, further enhancing the interoperability between different components. Redfish profiles define specific use cases or deployment scenarios. The OPAS implementation includes two profiles. These profiles specify the required schemas and properties to ensure compliance with OPAS standards. The profile approach helps standardize how Redfish is implemented across different systems, ensuring a uniform experience regardless of vendor. It is essential for compliance and provides a baseline that guarantees specific management capabilities will be available in all OPAS systems. Finally, a Redfish resource is an instance of an object defined based on a schema or profile. For example, a specific vendor control node. As you can see, the final instance is readable and easy to understand. The direct interaction with system components will be through the resources. To conclude, managing the lifecycle of OPAS components from multiple vendors can be a complex task, but we can simplify it significantly with the help of standards like DMTF Redfish. Our approach ensures a standardized, open, and secure interface for managing all system components, regardless of the vendor. The vision of a unified management system for OPAS components is not just about simplifying day-to-day operations. It's about reducing downtime, lowering risks, automating routine tasks, and ultimately empowering our teams to focus more on innovation and less on troubleshooting. With a focus on openness, flexibility, and security, we are ensuring that OPAS systems are effective today and ready for the future. Thank you for your time. I hope you found this presentation insightful. If you want more information, please visit our forum page, LinkedIn page, or contact me. We are eager to dive deeper into any part of the standard that interests you.